Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Technology. So in this session, I am going to explain about the crystal defects. The contents are lattice vibration or phonon, point defects, line defects, surface defects, and then volume defects. So here we can see what is defect. The crystal defects are imperfections or deviation from an ideal crystalline structure at the atomic level, resulting from factors like rapid cooling, deformation, or high energy radiations. These crystal defects can be classified based on the dimensionality. So here we have 0 dimension as a point defects, 1 dimension as a line defect, 2 dimension as a surface defect, and then 3 dimension as a volume defect. So in 0 dimensional defect we can see vacancies, impurity, Frankel defect, and then Schottky defect. In 1 dimensional defect we can see the dislocation and disclinations, and then 2 dimensional defect we can see grain boundaries, twin boundaries, and stacking faults. In 3 dimensional, twins, pestipides, voids, porosity, and inclusions. These can be discussed. So first one is the lattice vibration. So lattice vibration is nothing but vibration of the atoms from that position. So this is because of the heat transfer. So due to that heat transfer, the atoms can be displaced from their own position. This is called the lattice vibration. So here we can see the point defects. So point defects are the irregularities or deviations from ideal arrangement around a point and atom in a crystalline substance. So it can be classified into two, that is non-atomic crystal, that is ionic crystal. So in non-ionic crystal, vacancy or interstitial is there. In ionic crystal, Frankel defect and then Schottky defect is there. So in this picture we can see some point defect. So first one is the substitutional impurity. This is nothing but the foreign atom can be replace the parent atom, and the interstitial self-interstitial means the same atom can be placed in the interstitial position, and vacancy is nothing but the missing of the atom, and interstitial impurity is nothing but the foreign atom can be placed in the intermediate position of the structure. So next we can see the Schottky defect. So in Schottky defect, the pair of ions, that is nothing but positive and negative ion, together can be missed from the places. That is called Schottky defect. So Frankel defect is nothing but the smallest ion, that is the cation, can be missed from their position. That is called a Frankel defect. Next one is the one-dimensional defect called line defect. So this is nothing but irregularity or deviations from the ideal arrangement in entire row of the lattice point. So here the interatomic bonds that is distorted in the intermediate of the dislocation line. This dislocation affects the mechanical property. So from this picture we can tell about the edge dislocation. Here the partial insertion of the line of the atoms between the intermediate position. So here we have a positive edge dislocation and negative edge dislocation. If the part of the atoms inserted from the top to bottom means that is positive, or if that is inserted from bottom to top means that is the negative edge dislocation. Next one is the screw dislocation. So this is nothing but the one part of the atoms dislocated from their position. So like screwing the things, this is called the screw dislocation. Next one is the surface dislocation. That is nothing but these are associated with the boundaries and that are separate regions of the material and have a different crystal structure. This is comes under the two-dimensional defect, and this defect will affect the mechanical, electrical resistance and corrosion resistance. So here we can see some of the surface defects. The first one is the external surface. So here we have the unsatisfied atomic bondings. In the grain boundaries we have a separate regions. The grain boundaries can be dislocated from this their position. So here we have a low density in grain boundaries, that is high mobility and high diffusivity. Tilt boundary, so this is nothing but between two slightly misaligned grains appears as the arrangement edge dislocation. So here the rotation axis is parallel to the boundaries, and in twist boundaries the rotational axis is perpendicular to the boundary plane. The bulk or volume defect, this comes under the three-dimensional defects. So here we can see the pores, cracks and then foreign inclusions. So pores affect the optical, thermal and mechanical properties. Cracks affect the mechanical properties, and foreign inclusion affect electrical, mechanical and optical properties. Thank you.